Now let's take a look at ISDN. ISDN was designed for the purpose of creating an end-to-end digital communication. Let's take a look. Say, for instance, you're wanting to dial your ISP over here. Here's your ISP. And you're on your home computer. You're wanting to connect to the internet. The ISP provides you with a connection out to the internet here. Here on your home computer is speaking in a language, in digital language. Whereas here, the telephone lines are analog phone lines. So in order to communicate from your digital PC to the analog phone lines, we have to have a device that will modulate the signal and then demodulate the signal at the other end. This is called a modem or a modulator-demodulator, where we modulate from digital to analog. Interesting thing that happens though, inside the telephone company's cloud, the PSTN, you'll note that they're using digital signaling inside the cloud. And then, of course, the phone lines on the other end are analog signals, or analog phone lines there. And then, of course, we have another modulator-demodulator, another modem connecting to the ISP's server where that device is digital. So we go from digital to analog to digital to analog to digital. Wouldn't it be nice to be able to go digital end to end? This was the thought process behind creating ISDN. ISDN, once again, is a digital end-to-end interface, a concept that provides digital end-to-end communication over regular phone lines. Let's take a look at some of the ISDN standards. ISDN includes 3 standards: the E series, the I series, and the Q series. The E series is your telephone equipment, your existing telephone equipment. So if you see an E163 or an E164, that's referring to the existing telephone network. The E163 is the international telephone numbering plan that we're used to seeing going back and forth. That's an E series. The I series, these are ISDN concepts and aspects and interfaces. Also, you could sort of call these ideas. These are the concepts, the aspects, the interfaces of ISDN. I100 or I400 being the UNI, the user network interface. So those are the I series, ideas. That'll help you remember it for the test. And then there's the Q series. The Q series is the switching and signaling. I couldn't think of anything cute to say here, so we'll just say signaling. So those are your ISDN standards. Now, ISDN offers us a couple of different access options. These are BRI and PRI, Basic Rate Interface and Primary Rate Interface. Basic Rate Interface offers us 2 B channels, 2 bearer channels, and 1 D channel, 1 delta channel. The 2 B channels are each 64K. The D channel with ISDN, BRI, is 16K. The D channel is used for signaling, to set up or tear down the link of communication, and then the B channels are used to transmit or bear the data itself. PRI, ISDN PRI, comes with 23 B channels and 1 D channel. Now this is the North American standard for ISDN, 23 B channels and 1 D channel. By the way, these B channels are also 64K, but the D channel with PRI is a full 64K itself. Once again, this D channel is used for setup, for signaling purposes, to set up the communication, and then the B channels, the bearer channels, are used to bear or transmit or carry the data itself. This is the North American standard right here. This is also what we refer to as T1, rate of communication, which brings us to 1.544 megabits per second, whereas E1, which is used in Europe and in other parts of the world, the PRI standard there is 30 B channels, and then you've got the 1D channel. Call setup takes place, as I mentioned, across the D channel, where we've got a router here, and then the ISDN service provider's cloud. You've got another router here. The D channel is always up. The D channel is always up, and then you've got communication between the switches here. When we want to place a call or we want to bring up the connection, signaling takes place first across this D channel, informing the ISDN switch here that we're wanting to place a call or set up the link. Then the switches bring up the link here using SS7 between the switches inside the cloud here, and then the signaling is set up to the other end, at which point now the B channels come up, and that's our fourth step. The B channels come up end to end for data to transmit. Now it's important to note the different ISDN functions. Functions with ISDN, this is the hardware. These are the hardware devices in ISDN. You'll have what's called a TE1, then we've got TE2, we've got the TA for terminal adapter, then there's NT2 and NT1, and then out here we've got the ISDN service provider. Each one of these is a different type of hardware device or a different hardware function. Different hardware will actually combine some of these functions together, but sometimes you'll have each one being a separate device. A TE1, Terminal Equipment 1, this is a device with a native ISDN interface, like an ISDN phone or a router with the BRI interface. A TE2 is a device that does not have a native ISDN interface, and say for instance, let's just throw in a router here. We'll use this router. This router is a TE2, and we'll connect the serial interface here to a terminal adapter. So serial 0 connected to a terminal adapter. This TE2 does not have a native ISDN interface, and so has to have an adapter to make it possible to connect this device to the ISDN network. The terminal adapter might connect into the NT2 as well as the Terminal Equipment 1 here connecting into the NT2. The NT2 is going to be some type of switch that will provide access to multiple devices so that they might access the ISDN network. If you don't have multiple devices that need to connect to the ISDN network, then there's no need for the NT2. Then you have the NT1. The NT1 is what will provide us with direct communication or direct access to the ISDN network. The NT1 converts the ISDN network's rate of communication over to the communication that we'll have internally to our network. Now, between each one of these devices, there is what's referred to as a reference point. The reference point, this connection right here between the TE2 and the TA, the terminal adapter, this is called an R reference point. The reference point between the TE1, the Terminal Equipment 1, and the NT2, this is referred to as an S reference point. Between the NT2 and the NT1 is the T reference point. And then between the NT1 and the service provider, of course, this is our local loop. You'll recall this is our local loop or our last mile right here. This is the U reference point. Now, the reason why this is important is because, say for instance, on a router that you purchase, you have a BRI interface on that router. The BRI interface is BRI 0 as the interface, and it has an S/T labeling on the BRI interface. This means that you can take this router and plug it directly into an NT2, or you can take this router and plug it directly into an NT1 because of the S and because of the T. Now, if this router does not have the ISDN interface and instead has the serial interface, remember you plug it into a TA, which is the R reference point. But if instead that BRI interface is labeled with a U, that means that you will not take this router and plug it into an NT2 or an NT1. That means that the router already has an NT1 function built into it, and this router can be plugged directly into the local loop here. So that gives us a basic look at ISDN.